Okay, hello everyone. Today's session, I think this is module chapter 4, IP routing basics 4 or 5. Basically here we discuss routing. After data IP addressing, where we discussed every node, every host in a network having an IP address as an identifier, then every IP address belonging to a subnet. Uh, how then do subnets communicate with each other? How do networks communicate with each other? Yeah. In between, we have a device that runs a router, which basically breaks down my broadcast domains edu, and it is responsible for forwarding my packets efficiently to their destination networks. How it performs that role, it makes use of what we define as routing, which is basically a process of selecting paths on a network along which packets are sent from a source to a destination. So I think this chapter basically builds up on what we did in IP addressing, then following up with subnetting. Objectives of this one is to understand the basic principles of routers, know how routers select optimal routes, understand contents of a routing table, then master advanced routing features. That is our overview. Starting with the background, inter-subnet communication. An IP address uniquely identifies a node on a network. Each IP address belongs to a unique subnet. To implement IP addressing, subnets in different areas needs to communicate with each other. So I think that was my introduction. Uh, Subnets in different areas need to communicate with each other. How do they communicate? They communicate via the router, via the process of what we call routing. So I think that is what we'll basically focus on in this module. Routes, a path information is to guide packet forwarding. A router is a device that forwards packet to the destination. A routing device maintains an IP routing table, right? So how a router performs its duties, the routing, it makes use of what we call the IP routing table. So basically, IP routing table, it contains all the routes that are known to the router. So if I give an example, is it too early? It might be too early, but I think let's just summarize the routing table as a memory that is on our router where all the routes, the paths, then going into all the networks that the router knows they are stored there. So well, let's give an example. So let's say, for example, router R1 here. It knows there is a network here. Let's go network 1 here. Let's go this network 2. Let's go this network 3. There is another network 4, probably network 5. This is another network 6, 7. Right. The routing table will contain this information. Network 1, 2, 3, 4, 5, 6, 7. And how are they known? Some of them will be known statically, manual configuration, some will be known dynamically, some will be directly connected networks, directly connected interfaces. All that information get one from the routing table. So the routing table, in short, it stores all the information about what routes your router knows. Then going to routing information. cannot see perfectly. Yeah. Routing information. A route contains the following information. The destination, basically, that's the destination network, the mask, that's the subnet mask, the outbound interface through which a data packet is sent out of the local router, then the next hop, the IP address used by the router to forward the data packet to the destination. That is some of information that is contained in a route. So example yatinayo, we have a router up here. And there is routing information about this network here up. By default, information in router, my routes are in router. We have what we call my directly connected networks. So information interface up, and the consequent network iripo do inenge irimo muno routing table redu. So let's have our routing table here. So number one, by default, you see what we call my directly connected networks. Do anenge arimo mu routing table redu. My networks are remote like this one. It's not directly connected. If I'm looking at this router, this is the network that it knows and only this one because it's directly connected. But this one is remote. It's not directly attached to this router. So for our router to know a network that is remote, then it will need that route configured on the router. Or it will need my routing protocols to update routing table so that we know there's a remote router repana. Information in repo if a route is configured. Obviously, you have the destination network, and its subnet mask. Then this is the outbound interface, also known as the exit interface ERIR. It tells information ikauya router node and is destined for this network. Where do we forward it out of? We forward it out of this interface ERIR so that ikwanise kuenda kwekuenda. That is what we call the exit interface. Then the next hop, it defines the IP address where we are going to forward packet redu next. So in this example, next hop, IP address ERIR. So if I want to forward a packet to 10110, what do I do? If I want to forward a packet to 10110, packet rikaya panapa, destination network yacho iruta route inofanira kusvika kunoko. I will forward it via this exit interface, then to this next hop IP address. Ikasvika panapa, this router will know because it's directly connected to the destination network. Via forwarder directly to this one. I think I've summarized, not summarized, I've touched probably on quite a number of things, but these slides summarizes what is contained on a route. Route really proper. It contains this, the network, destination network, its mask, exit interface, and the next hop. There we have an example of a routing table. Routers discover routes using multiple methods. Router selects the optimum route. It stores it on the routing table. Router forwards IP packets based on routes. Routers manage path information by managing their IP routing tables. Right. This is an example of an IP routing table. So basically, it's showing a routing table at this device, I think, R2. So by default, that's where we start. By default, we know that the routes that are known anototanga kuenda routing table maroute directly connected interface. So for example, this interface ERIR, I think network 111.130, I think ERIR. That's a directly connected network. inenge iri murouting table. Two networks are up. This one is directly connected. This one is directly connected. 222 ne hapo. I'm not seeing them. Right, 2221, 331. They are not here. Routing table is not complete. Then there are other networks. Let's look at them. My remote networks. I can see this one. 11000. I think no network irapo, a remote network. And if you look at it, so far, the next hop, if I want to get here from router number 2, I go via this next hop IP address, no 222 irapo. This is the next hop IP address. Then our exit interface is Giga Ethernet 00, which is this interface up and the exit interface. So if I want to get to this remote network, ndinoshandisa route iri apo. Another example, route 13. This becomes our next hop IP address. This becomes our exit interface. Kana ndichida kusvika kunoku from router number 2, ndinopfuura nepa-exit interface iri, outbound interface. Then ndoenda pa-next hop IP address iri. Then ndo ndasvika pa-network yangu. So this is just a summary of what the routing table shows us and how a router uses the routing table to choose the destination network. Then we go to how to obtain routing. How to obtain what? Routing. Let me see. Right, how to obtain routing information. A router forwards packets based on its IP routing table. To implement route-based packet forwarding, the router needs to obtain routes. The following describes the common methods of obtaining routes. Right, how are routes obtained? Routes are obtained either by what we call my direct routes. My direct routes, though I'm going to mention and my directly connected networks. So our interface, very directly connected, directly attached to a router. It leads to my direct routes. So router iri, door we show routing table upper E. This interface is directly connected R2. My networks are ipapo. Ndo ari kuenda pa-routing table iyi ndo anonzi ma-direct routes. So I can see network iri apa 2110 ndo iri apa. Then I can see imwe 10110 ndo iri apa. So that is what we call my direct routes. How to obtain routing information? Information in routing table, it can come from my direct routes, number 1. Number 2, it can come from what we call my static routes, which are basically manually configured routes. It's a route really configured. So in this example, routing table head and router iri apa. My directly connected in the eye. This network is remote, meaning by default, inenge isimo routing table. There will be need for my routing protocols or a static route to be configured so that we can be able to send packets to that network. So in this example, static route error, Dora configure, and you can see protocol panapa is different. Panapa is direct, panapa is static. Destination network yedu, mask yedu, exit interface yedu. Kana ndiri router rinori, kana ndiri kuda kusvika network ishi, exit interface ndoshandisa ndeipi ndeino. If we were to put the next hop IP, it will be the IP address of this interface irapa. In this case, haipo. Number 3, my routes, they are linked by what we call dynamic methods. At not my dynamic routes, they use my protocols, which updates my routers edu over time. Right, example, iripo iyo ndio OSPF. Again, you can see the protocol OSPF, destination network yedu, remote router redu, kushow routing table nderino. If I want to get to that remote network, how do I get there? I use this exit interface. That's the outbound interface. And basically, those are three ways that a routing table can be filled. How my routes edu are known basically. On our direct routes, a direct route is automatically generated by a device. We've touched on that. When a router is the last hop router, IP packets to be forwarded will mesh a direct route, and the router will directly forward IP packets to the destination. When a direct route is used for packet forwarding, the destination IP to be forwarded and the IP address of the router's outbound interface are in the same subnet. So I think basically you realize my direct routes are sort of the last hope. If you are sending information to any destination network, then direct route no longer last hope. Example, if I'm sending information, no, let me draw my routes. I'm going to go. Right, so let's say I have my routers ARM3i. This is network A, this is network B. If I want to send information to B, information payanosvika parouter iri kuti ichiende ku B, iri route iri directly connected. So if you are sending information to any destination network, you realize that the last hop is always a directly connected network. Therefore, a directly connected network ndo rinopedza basa rese. So if I'm routing panosvika panapa, I am a direct connected asiro my destination network anorouta futi kuendesa kumwe. Iro routa kusvika panapa. But panapa haticharoute kuenda ukoko. It's more a case of forwarding. Takuita packet forwarding to the destination. So tikasvika but the last hop, which is a direct route, the process inozoitika ipapo is more of packet forwarding rather than the process of routing. Packet forwarding. If networking yedu iri deep pichana, ndopanotanga itika the process of ARP, where we map our IP address, the MAC address of the destination device, then packet ready from forward to the destination device. I think that is basically what is being summarized with this slide. Not all direct routes generated for interface are installed in the IP routing table. You're going to realize with the routing table, it's not every route which will be there. Number one, my routes are most preferred. Ndo anoiswa routing table. In the case of my direct routes, you realize that if an interface is down, for example, then that route will not automatically be in the routing table. Because there's a routing table RTB, router B panapa. Interface E is up, therefore network E, the minimum routing table directly connected to network E rapai. Interface E it's down, shut down, it's not enabled. Therefore, the protocol is not up, therefore, routing table redu hatiruone, even if it's directly connected, but just because it's not enabled, we won't be able to see it routing table redu. To extend this to other routes, not all routes dziripo network are installed per routing table yedu. I think we'll go through my preferences, we'll go through my metrics, my cost, same thing. We're going to realize that a route from routing table, it will depend on quite a number of factors. Going to examining the IP routing table. Routing table yedu apa takubudisa marouting table chaiwa. You can see under the destination network, the mask, we've touched on this. Under the protocol basically shows us how that route was lent. Route roro rakapinda same routing table. It can either be direct, which is a directly connected network, static, manually configured, or it can be dynamic, example, OSPF. Then we have the preference, by definition, indicates the routing protocol preference of the route. There may be multiple routes. Here we are. To the same destination, which have the next hops and outbound interfaces. These routes may be discovered by different routing protocols or be manually configured, blah, blah, blah. In short, the preference is also what we call, if you did Cisco, this is what we call the administrative distance. And it tells us the router which source to trust if there are multiple routes to the destination. So example, network yangu ine 3 routers. B, A. So if I want to get to B, I can either go via this route number 1 or route number 2. This is no gonna B. But which one is most preferred? Which one is most trusted? So depending with the preference, with my numbers higher, the lower the preference, the more trustworthy the route. So ndikaisa, in this example, static ine 60. So ndikaisa kunoko, a static route rinosvika kunoko. Zvinoti inenge ine preference ye60. Ndikaisa another example, a direct route. Okay, we won't have a direct route. Let's have your OSPF. AD OSPF is 10. It's a bit confusing in Cisco. AD OSPF. So let's say router kunok side kunok. It was dynamically linked in OSPF, meaning preference here is 10. Ndikatasa routing table router iri. But 2 routes are kusvika kuna B. Which one will be in the table? Iri ndo rinenge rinova mutable iri. This one you won't see it. Why? Because preference yayo is higher. OSPF ndo riri more preferred, ndo rinenge riri routing table. So preference, it shows us route most trusted. That's another way you eliminate my routes more routing table. Route most trusted ndo rinoiswa more routing table. So that's the preference for you. Then we have cost. Cost, that's a metric that is used to select the best path among multiple paths of the same type. So let's say, for example, let me see how they defined it. Indicates the cost of the route when multiple routes of the same destination have the same preference, the route with the lowest cost will be selected as optimum route. Right. Let's give another example. Example at upper face panapa. Yange a different type of routes. Iri static iri OSPF iri. SROska kuna B. Akasiyana. So which one is most trusted to notarisa preference? But what happens if for that same network to get from A to B, panapa ndakashandisa OSPF, panapa ndakashandisa OSPF. Ese ana value 10. Ese ana value 10 my preference. What then will I be using to compare? Ndo panopinda inonzi cost. In the example OSPF inenge yakutarisa the bandwidth pamalinks edu. So total accumulated bandwidth palink iri nekubva apa kusvika apa inenge ine shoma, inenge ine yakawanda bandwidth, inenge ine lower cost. In a lower cost, ndo route rinova preferred over the other. So this cost It's more of kana ma-preferences edu akafanana. Then what will be a tiebreaker? Ndo panopinda iyo inonzi cost. Then tine next hop ne-interface. Iyi ndo exit interface iyi. Next hop we've discussed it, ndo IP address where our packet will be forwarded next. Then to end up, I think this basically summarizes information yes ma-fields ese ari ma-routing table. Then to end up, route preferences, basic concepts. When a router obtains routes to the same destination subnet from different routing protocols, the router compares the preferences. I think that is what we've been talking about. Same destination, two different protocols. What do? We compare my preferences and prefers the route with the lowest preference value. A lower preference value indicates a higher preference. The route with the highest preference is installed in the IP routing table. So my routes edu tikacheka the destination network ikamecha, if we have the same preferences, no, if we don't have the same, tikacheka ma routes edu and we check the destination network, totalisa if we have two protocols, totalisa ma preferences in a higher preference, ndo inonoiswa mu routing table. I think this is a bit confusing, but basically, if we are talking of comparing route preferences, tine two ma protocols, let's put it this way, in a lower, ndo inoiswa mu routing table after comparison. Then on this one, we're looking at a more practical example now, comparing route preferences. So we have RTA, which has two routes to network yedu 10.0.0.0. So if we are looking at RTA to get to this remote network, RTA discovers two routes. One is an OSPF and the other is static. Compares the preferences. Each routing protocol is a unique preference. OSPF is high preference. Therefore, it will be installed. Right. So to get to this network from here, we can either go via this one or via this one. I think there is a static route, this one, this is 10.0.0.0, via which next hop 10.1.1.2. So static in the ear, next hop here is the ear rabbi. So static route in the ear rabbi. Then the other one, 21.1.2, the rogi, the OSPF ear. So which route will be preferred and installed in routing table? E route in a lower preference. Static in a 60, in a 10. So this one, you won't see it if routing table is. Your no routing table is the one in the OSPF. For those vakaita Cisco, I think it might be a bit confusing because for Cisco, static is actually in a lower preference. I think OSPF in a AD value here, it should be hey, 90. Anyone is Cisco, it should be 90. Static, is it not 1? Quick Google to find ADA OSPF. Anyone? Or an easy name, so Cisco, not Huawei. It's a bit different. It's worth noting. Then we check quickly. OSPF AD.
E110.
Is it E110? It's 110.
Yeah.
Right, it's 110. Ko static issue. Static issue.
Static, I'm not sure of the right figure, but it is preferred than OSPF.
It's preferred over OSPF, right?
Yeah.
I think static it should be 1. let me see. Yeah, E1. Right. So this is for Cisco. So kuno Cisco static is preferred over OSPF any day, but kuno is vice versa. I think it all depends on my vendors. Static, I think reasoning yeku Cisco is static iwewe sa engineer ndiwe waita manually configure route. So we are going to trust you with that route. But on the flip side, I think my static they have a problem ukuthi they don't automatically update. So likiroro rikadhakwa routing table static rinoramba irimo even link racho risisashanda. So on the flip side, OSPF or other routing protocols, they are more preferred than static because my dynamic routing protocols, they continuously update. Link rikadhakwa routing table to update kunzi link radhakwa, so another route will need to be installed mutable imo. So I think that's more of an explanation of reasoning why on one end static really more preferred, on the other end OSPF is more preferred. Then tender per metric, another comparison cost. So I mentioned what happens if my preferences are akafanana. In this example, RTA lends two routes with the same destination and preference through OSPF. The two routes have different metrics. The OSPF route with the next hop is a lower metric. Right, in this case, to this destination network, preference is 10 here, OSPF is 60. No, it's 10. That OSPF is 10. So OS preference here is 10, preference here is 10. Kana my preferences akafanana, then we start looking at my cost as my tiebreakers. So cost in this case is more to do with the bandwidth. If we are talking OSPF, cost with respect to OSPF, we usually talk of the bandwidth. So ungatarisa cost yakaiswa panapa is 10. Cost yepanapa is 10, ye-link iri 10, ye-link iri 10. Saka to get here, you realize with cost yekubva panapa kusvika apa is 10 only. Yekubva up kusvika up, cumulative it's 20. Saka kune cost shoma, I think i-link iri apa. So ndo rinoiswa murouting table. Iri rine next hop iyi rina 3112. 3112 ndo richaiswa pai murouting table after we've made my comparison in my matrix. My comparison in my matrix or my other types of my cost, we have, for example, in the RIP, RIP, just say not hop count. So let's say my preferences, they're the same. RIP is an instead of using the bandwidth, you have to get to the destination, what's the hop count? Like my routers are upfura. Ndikapfura one route is one hop count. Ndopfura another one, 2, 3. Ma counts wa mangani. Kuni mashoma, do lower cost, that's the preferred route. That's another protocol using another metric. But I think for this one, we're using OSPF, its metric is bandwidth. Common default values, my values are ndekuziya nemusoro mamwacho. To me, it's a bit confusing, mostly because of Cisco. But ndekuziya nemusoro. Direct route 0 preferred than anything else. Why? We trust the router and its interfaces. I think that's why it's most preferred, this one. Then we have my static routes, OSPF, internal route, OSPF, external route. We trust an internal route more than an external route. Then to end up basic concepts, comparing metrics. When a router discovers multiple routes of the same destination through the same routing protocol, The router selects optimum route based on the matrix of these routes. If these routes have the same preference, I think we've touched on that. Common metrics, they include hop count. This is for RIP, OSPF bandwidth. Others, take a look at delay, load, reliability. Kana reliability pasina, therefore cost inenge yakawanda, therefore that route hariiswe murouting table. So it's another metric that is used. The metric is also known as the cost. The route with the lowest metric, I think we've touched on that. So Maraus Edu, we take a look at the destination network. If we have the same preference, how do we interpret this thing? I think we've been saying everything the correct way. Someone interpret this table and let's read it so far. I'm failing to figure it out. If table flowchart, someone interpret flowchart hero using kana preference dzakasiyana or dzakafanana or matrix kana takuma compare. Anyone help me?
Okay, let me try
Yeah, well,
to interpret it. For my route side one, I think it's saying when the router learns a route, then it knows the destination kuri kuendwa nepacket yedu. The first thing chainotarisa is the preference before the metric. So ichatarisa preference. If it's the same, not tichiri padestination.
Yes. Tichiri pana.
Yeah, pekutanga papa undiconfuse, but it prioritizes preference over metric.
Yes.
Ndo the first thing. Saka preference yedu yakaonekwa kunzi yafanana, same preference, it jumps onto the metric side. Yochitarisa metric kuti how can we then differentiate or try to break the tie.
All right.
So kana tiri preference apa ikatongoona higher preference, it doesn't like waste time ichimbodzoka kumetric, yakutongoenda directly kunoinstalla murouting table. Then if the preference is the same, ichabva yaenda towards the metric side. Metric ndo richabreaka tie yobva yadzokera kunoinstalla murouting table.
All right, thank you. I think time here means another session. Use the same link. I think in 3 minutes we'll be up.